There we go. All right. So first steps with Docker. We'll just jump right in. So old world problems, I guess, pre-container problems, rickety software delivery pipelines, different application behavior depending on the environment or the infrastructure, resource utilization, especially pre-virtualization. Machines weren't being fully utilized. Virtualization helped with that, and containers continue to kind of improve resource utilization. Containers will improve resource utilization, but pre-containers that's a problem. And in software administration, it's not like a sexy part, but just it's kind of a pain just installing software, downloading it, uninstalling it, getting the dependencies. I recently tried installing Bamboo on Windows, and that ended up being kind of a small nightmare, just with which version of the JDK did I need. And at first I thought I just needed the JRE, and I've got a set of instructions to install Bamboo on Windows, but it's just kind of maddening that I had to go through that for two pretty big pieces of software that are pretty popular. So these were kind of some of the problems in the old world. So solutions are containers, or one of the solutions. So containers are isolated processing environments, which a lot of you guys know since you're familiar with Docker. Container can include its own network and storage, its own file system. There is a broader host system that houses containers. So think like a big Linux box that hosts several different containers. That would be Linux as well. Here you can see package, say Nginx, Python. You got Linux OS in there, got its own file system, Django, and some networking. But that's the idea, is to include everything inside the container with as minimal amount of code as possible. And it's in order to be lightweight. So, you want just a minimum requirements to run so everything runs fast, and it's not as much of a resource hog as, say, a VM would be. So use cases for containers. I kind of lump these into three broad categories related to deployment, production, and development. So creating predictable deployment environments, this is related to the first world problem of rickety deployment pipelines. The way, a container, if you have your container software on a system, if you have said container that works on that software system, that should work on any machine that has the same container software. And so you can wrap up an application, test it out in dev, vet it, then port that into your QA environment, and in theory, it should run exactly the same way it ran in the dev environment, regardless of the underlying infrastructure. Same deal with UAT, same with production even. And so this really helps with different deployment types, blue, green, rolling, Phoenix deployments. Taking that further, so if you take your containers up into prod, that helps you to really utilize your production machines even more efficiently. You can pack more containers on a machine than, say, a VM, which contains an operating system and a whole host of other things. You can also quickly scale out your production workloads with containers. They're easier and faster to spin up and spin down than, say, a virtual machine. So you can think of a fleet of web servers that are running in the containers. If you've got increased workload on your application, you can quickly spin up other containers to kind of help with manage that workload and then spin them down when traffic subsides. And then finally, development environments. While I was trying to come up with this presentation, I'm not a developer by trade, but Ryan, who isn't here, he asked me a few months ago, as a developer, why would I want to learn to use Docker if I'm just developing? And so I've kind of been keeping that question in the back of my mind as I've gone through this. It seems to me a lot of the benefits of containers is when you try to share containers, say, with other people or with other environments. That's where you get a lot of the big benefits. Just developing, containers won't make your software faster or more robust or anything like that. But with respect to the software installation, it's great to be able to quickly just say, hey, I've got Docker installed on my system. I just want to take this container that has this software, should be fully packaged and ready to run, and like in 2 or 3 lines, I've got to run it on my system. It's a light footprint, and I didn't have to go through different websites, different instruction sets, going to Stack Overflow when I bang my knee trying to install software. So even if you're not planning on creating a deployment pipeline or putting your containers in productions, you're just kind of developing on your own, Docker can still be a benefit just with respect to the software installation. Yep.
What is the difference exactly between containers and virtual machines?
So I think for me, the biggest difference is a virtual machine has its own guest operating system kind of baked in. And so you can have a Windows VM that could, in theory, I guess could run on a Linux box because it has its own Windows operating system, and it will utilize the hypervisor on that machine. So that's great. You can run Windows anywhere, as long as the hypervisor's there, but you're lugging along this huge OS and whatever else comes with that. And so it's more resource intensive, the VM. It takes longer to spin up, longer to spin down, just because you have more stuff that you're trying to pack and unpack.
You can also make out a container easier, like the security. Lower because a container share
The OS.
Or they share portions of the OS with the system.
Yeah.
As opposed to a VM, which has its own IP stack and all that. Containers share.
Right.
So I guess my question would be more, I understand the pros and cons. It's just like when I think of a virtual machine, I think, the program that runs on the OS simulates another OS, right? And then everything goes through it and eventually goes to the main OS. Well, what exactly is a container other than the program? Like how does the ISO read? How does it package the software?
Yeah, so, and I'm getting somewhat out of my depth here, but there's a slide coming up here where it shows the enabling technologies that a container utilizes. So kernel namespacing. So like we were saying, you're sharing the OS, but you're using kernel namespacing to say, okay, container, we're gonna carve up these resources for you under this namespace, and we're gonna kind of dedicate this for you. And again, other containers would be doing the same. You also have control groups that you can use to limit the resource usage for any given container. But those two are two of the big technologies that kind of allow you to isolate this container on this host system that's sharing the same OS kernel with other containers. Now, because of the kernel namespacing and the control groups, it's kind of cordoned off into its own playground. I know that's not perfect, though. I've read some horror stories like Docker in particular. If you read Docker blogs from a couple years ago, it sounds like it was really horrible, the security. It sounds like that's gotten better, though. I'm not sure if that's truly the case.
Yeah, we're on a older version at work, but to get Swarm to work, you have to bind to the outside socket on the machine to expose the entire Docker API to anyone who has access to that IP.
Sure.
I think that's what's changed now.
Yeah.
Secure with some channel, but this wasn't. This is like the current version in CentOS 7 that isn't in one of the, higher, the more future repositories, right? Like the stable CentOS 7 kernel is still using.
Yeah, that's. Oh, yeah. I thought 112 was the one where that's where you get the goodness. Because I started messing around with Swarm, and it seemed like it was pretty. They baked in some security features with.
I don't know. Jenkins to start the containers in the development site. You have to bind to the socket.
Okay.
Expose it. So, I don't know. I think there's some. I think it's come along. I think there's a huge difference between 112 and whatever. Now 123, right? Because 113 is you just shrink, whereas.
I have no idea. Right on. And yeah, so that still may be the case, but your point is, Docker has come a ways security-wise to where even 2 years ago, I'm not sure if it was truly prod ready. I think it's production ready now, maybe not across the board for everything, but yeah. So did that someone answer your question? Or?
This is just one thing, and I don't want to hog too much of your time, but the idea is that you can still spin whatever OS you want. Right? Like a container.
No, whatever the OS is of the host system. For the most part, with Windows, there is a wrinkle. So with Windows, you can use Windows 10, the Hyper-V or whatever, you can run Linux containers on your Windows box because you're essentially using the small hypervisor that's kind of baked in. And then on the Windows 2016 server, it's the same deal. you can enable Hyper-V. But yeah, for the most part, think of it just like that. And that to me seems to be the big difference between containers and VMs is that OS. And here's Ryan.
At a very high level, I consider Docker to isolate processes versus VMs isolating OSs in general.
Okay.
I mean, even to a bigger level.
Right on.
That's very high level.
Sure.
Not even.
I've heard also VMs isolate hardware. They somewhat directly hit the hardware resources. Yeah. And I guess is that because they're using the hypervisor to kind of bypass the OS? Is that what's happening, or?
At the highest level, like all of the, if you're running multiple virtual machines with different processes, there's all those pieces that are basic pieces of the operating system that the process doesn't need specifically, but the OS needs to run. And what containers are doing is they're taking all those pieces and only having a single installation of it. Each process is reusing that same installation of the core operating system.
And the core operating system is still what they host operating
Yeah, so
system.
your host operating system, what your host operating system, your desk OSs are only very, very lightweight footprint installations that are making use of the host operating system.
Cool. So yeah, Ryan's the one that asked me about, as a developer, why would he want to use Docker, and was explaining, I'm trying to somewhat answer that question. Software installation becomes more of a breeze, I guess, using Docker containers. So anyways. So the container landscape, just kind of, as I say, just kind of some of the bigger pieces. You got Docker, it's been around since 2013. Linux containers, which used to be known as LXC, which I think stood for Linux containers, but now I guess they're known as Linux containers. And I think initially Docker just leveraged that technology for the most part, but that's no longer the case now. Windows is now into the container game, but Windows 10 2016. CoreOS is a different set of people, didn't like the approach that Docker took to containers, so they came up with their own operating system, which was container, I guess, specific, and Rocket RKT is their container technology. So the first implementation of that, I just saw as I was creating a presentation that they've changed their name to Container Linux now. And I'm just pointing it out just to kind of show that even though some of the technologies that these containers are leveraging are old, the container space in this current form is still kind of new and dynamic. And like you're talking, the security stuff, 2 years ago, massive holes. In 2017, still holes, maybe not completely massive, but, it's improving, but it's a fluid space. And then so the Open Container Initiative, people were starting to be concerned that there were these different strains of container technology. And so the Open Container Initiative was started to, come up with industry standards, and Docker's part of it. I'm sure the Container Linux Core OS folks are as well. I'm sure Windows is. I don't know if anything will come from that or if it'll go the way of kind of like ANSI SQL, where it's like, yeah, there is a standard SQL, but all the major database vendors kind of have their own flavors of it. That's probably what's going to happen here. But so that's something that's happening. So then Docker is the software that manages and creates and orchestrates containers. Just, allows you to separate your applications from your infrastructure, so you don't have to worry about the infrastructure in theory. As long as you can run this container, you should be able to run the app predictably. Packages an application and turns into a shippable and runnable image. A model that Docker has is build, ship, and run any app anywhere. That's the big promise. And so Docker, is a doc worker. And just in case the point isn't driven home enough, we've got these standardized containers. Before this happened, though, doc workers were paid handsomely because, loading stuff onto ships was like a game of Tetris, but with the advent of standardized container sizes, it became a lot easier and predictable to actually load up ships. So as long as whatever you're trying to ship can fit into that standardized container, it can ship, as long as it's not a dead body in there or anything like that. So, and that's kind of the same way Docker works. Put your software in the container, and as long as it doesn't blow it up, you should be good to go. And so Linux and Windows now are the two OSs that Docker runs on. I'm not sure about Mac. Does anybody use, is it? Okay. All right. So I should have included that logo as well. I think those are the three. So Docker, what is Docker? There are three tranches of Docker. One is the company that started off as a platform as a service company. I'm not sure what software they were selling, but, think something like Salesforce. They were just selling software to customers. And I guess whatever they were selling wasn't really doing it. So in 2013, they pivoted, to focus on their container software. And I think they just kind of, while they're trying to sell their software to customers and deliver software to customers, they kind of came up with this really, really nice and easy container distribution method. And so they decided to actually start focusing on that to sell instead of whatever software they were selling. So that's the company. Open source. Docker is written, I think, in Go, and it's open source. They recently renamed their open source to Moby. I think that's out on GitHub. I assume it has something to do with the little Docker whale or whatever. But they're trying to make it their code more modular and transparent. And then the runtime and orchestration engine, which is what we'll talk about. Docker, the way they're saying their setup is that they allow third-party products to plug into their ecosystem, but they also have their own solutions for you as well. And there's free Docker versions and paid versions as well. So here are those enabling technologies that help with the security concerns of just containers in general. This is not Docker specific. I think these have been old Linux technologies, been around for decades. But the kernel namespaces are really key. That's what allows you to slice up an OS into different tranches. And so you can isolate your process and your network and your file system. And then, like I said, control groups or C groups, the second one, that's what allows you to limit resource usage for any given container neighborhood. And then capabilities. I'm not as familiar with this, but it deals with, just dictating which root powers a container set can actually invoke. And then there's some other enabling technologies that have to do with kind of higher level security things. But again, I think these are just basic Linux technologies that have been around for decades. And so it begs the question, if Docker is leveraging these technologies, but they've been around for decades, then why did Docker, quote unquote, win? Why is it so popular? And I really think a big reason is just it made the software administration lifecycle so easy. Like I said, when Docker was .cloud, I think they were really just kind of a wrapper set of code around existing enabling technologies. And they created that set of code just to make their lives easier because dealing with the technologies directly was difficult. And so, you will see the Docker code is pretty intuitive. There's also Docker Hub, which is kind of like a GitHub for images. So you can store images and, it establishes trusted images so people can, star images, and it shows how many pulls have happened with a certain image, so you can see the trustworthy images if you want. Because when you pull from registries, you're pulling code, and so it could be malicious. And so having a centralized, trustworthy location like Docker Hub is helpful. It's modular and platform agnostic design. Another model associated with Docker, batteries included but removable. So that's really great as long as they truly stick to that. Docker has the tools for you, but it should play nicely with other third-party products. And then it's free and open source. So we'll show some code. So here I've just got Docker installed. And so, like I said, I'll have the installation instructions available. But once you have Docker installed, you can just run sudo, see what version of Docker. And this is what I was saying, I'm running 1.2.6, but I guess you're talking about the API version being 1.2.4. Is that where you're saying?
Because I had a problem before 1.13 is like, when you make an image, there's all those layers.
Yeah.
That blow the size of the work. And then there are all these third-party products to squish the image.
Okay.
They didn't include that until like 6 months ago.
Okay. I know. Now, yeah, this is the one I've always seen when I've spun up. But like I said, I've only been messing with Docker about 2 months, so. Let's see here. So once you have Docker installed, you can see what version you're running. You can also see the Docker commands that are available to you. There's a bunch that are kind of out the gate. And we'll go through some of these. Let's see. And if you want to drill down into any one of these commands, like say the build command, Docker is pretty helpful at giving you some help stuff. And it would look better if I had more space here, but you know, you just see the different options, and it's just nice documentation that you have just within a terminal. Again, keeping in line with the Docker makes this stuff just kind of easy, and that's probably why they're so popular. So then you can also see information on your actual Docker installation. A lot of the stuff I'm not necessarily going to drill into, but you can see we're running 0 containers. We have no images, see the server version, stuff like that. Shows you the different networking options that you maybe have enabled, which we're not really doing much with that. And so then here we're going to actually do the hello world for Docker. So Docker, you know, if you want to invoke a Docker command, it's Docker, and then the actual thing you want, the command you want to run, and then there's some parameters that you pass in. So we're going to pull an image from Docker Hub. So what happens is when you hit Docker run, it first looks at your host machine to see if you have that image. And if it doesn't, it'll actually pull from Docker Hub if you don't specify a registry, which I don't at all. And then you actually see, okay, it'll pull in the layers, and this image has just one layer to it, and we'll talk about that here in a little bit. And it downloads. And then this is the actual code inside that actually runs. And so this is just from the folks at Docker, and just like, hey, you want to just test out your Docker installation, make sure everything is on the up and up, there you go. And so here we can see if we what our running containers are doing. So again, Docker, and then you pass in the actual command. And right now we don't have any running containers. The way a container works is it'll run, but then when it finishes executing its code, it'll stop. And so if you want to see all containers, including running and stops, you would Docker PS and then pass in the A flag. And then you see we have this container that we just spun up about a minute ago. And yeah, let's see. Settings. Sorry, let me just mess with the font a little bit. Is that too small, or? Yeah. Do you guys in the back see that still, or? Okay. All right. So yeah, so you spin up a container. They give you, even though it's all jacked up looking, the container name. They'll give you like a funny little container name, or you can name the container yourself. Let's see here. We can also see what images that we have on our host now that we actually pulled down an image, and you see we have one hello world image. And so let's see.
That's showing you the images you have in your local.
Mm-hmm. Yeah. Or on my local machine now. So yeah. Let's see. Okay. We'll run another container.
So if you don't have that specific image that you type sudo docker run whatever, it just goes to the Docker repository and finds one that's pulled that name and downloads it and runs it.
Yep.
Like, does it base this on like trustworthiness, or like, let's say you mistype your image and you say set up like, you know, source, you say source C, and there's something online that's not trustworthy.
So I thought I was with you until the very end there.
You search somewhere for that particular image.
Yeah, absolutely. You'll know what image you want. So, I mean, I can just jump to, so Docker Hub here, right? So I could type in, hey, I want Nginx. So,
Centralized repository maintained by Docker.
Also, this is just Docker that allows
anybody can, yeah, think of it like GitHub, but like Docker is, you know, Docker kind of owns it.
Maintained by Docker, but the images that are put on there are community oriented.
Okay, so I guess my question would be like, whenever you say sudo run Docker
Mm-hmm.
and you say the name of the image,
Mm-hmm.
if that image is not on your local host, you will go up here, find whatever this image and run it.
Yep.
Let's say that this image is not trustworthy.
That's what I was saying. So this is a cool thing about Docker. One of the reasons why I think Docker is popular is because of, say, Docker Hub. So look here. We have what's known as official images. And so that's where, okay, you and I could not have an official repository on Docker, but Nginx can. Microsoft should, but they still don't. But like, you know, the trustworthy companies, the known companies, they'll have official images. So you kind of use that as your first filter of trustworthiness. Then you also have the number of stars, the number of polls.
It just seems really easy to me style your image and run on your machine.
Say that, I'm sorry.
It seems really easy to me style the image you want to run.
Yeah, you know, yeah. So that, I guess that could be a possible downside. It's too easy, right? So yes, if I typed in Nginx, put like an extra X, and maybe I'm getting something crazy. Yeah,
Right.
yeah.
The unofficial ones are also typically namespace. Maybe all of them are.
They all are.
So the likelihood of mistyping one that is also namespace.
Yeah, like if he puts in that Nginx proxy, he actually the front namespace is the person's account.
Yeah.
So it's very hard to
Right.
not get an official image.
Right. But if Jay Wilder wanted to be an asshole, right, and so he puts Nginx proxy with maybe IE or something, you know, and so I think I'm pulling something, but I'm getting something. But yeah, you're right. For the official, that would be tough to pull that off. Good catch. Yeah.
But
So
I think this is a lot like using an open source piece of software in your application too.
Yeah.
You gotta evaluate what you're wanting to use
Yeah.
before you use it. You just can't.
Well, that I completely understand. It seems to be like one command that like downloads and not something.
Oh, dude, yeah.
The risk of like,
Yep.
misspelling something and some from,
yeah.
other people.
Right.
It just makes more sense.
Yeah, the name spacing definitely helps with that. You're right. Let's see. Where were we? Oh, yeah, we're going to pull down Nginx. So, okay, so here we're doing Docker run again. We're going to pass in this D parameter, which detaches it. So again, the way containers usually work is they execute their code and then they stop running. But for Nginx, which is a web server, you kind of want it to continue running. So the -D flag allows it to kind of run in the background. -P is our params for ports. And so we're doing some port mapping here, and I'll explain that in a second. And then Nginx is the name of the image that we want to actually run our container from. And so when I do that, again, it doesn't see an Nginx image on my machine. So it's going to, you know, start pulling it from Docker Hub. And it's only Docker Hub because I didn't specify a registry. If I specified a registry, it would go to that registry. And so here you see, unlike the hello world that had one layer to the image, we've got, it looks to be about 3 layers to the image. And we'll talk about that in a little bit. And so we've got Nginx running. Let's see. And now you see we actually have a running container. And this is the name of the container. And again, Docker just kind of creates these names. If you don't name the container yourself, it'll name it for you with some kind of silly name or whatever. You also have a container ID, which is what I usually use to ID the containers to actually work with them. And so let me just run to let's get the public IP for this. So this is the EC2 that we're running Docker commands on. And so we just go here and we see Nginx is running, and I guess I probably should have showed it before Nginx. That's, you know, bona fide. But yeah, it's just that simple. You know, we're running Nginx, and granted, we haven't really done much with Nginx, but one command was able to do everything in a matter of 20 seconds to get a web server up and running. So I think that's pretty cool. Let's see here. Oh, yeah, and same deal. Well, we'll just see the images as well. So just like we could see the Nginx container running, so now we'll see that we have 2 images, the hello world and the Nginx.
So when you pull down and install the Nginx container, the configuration files, like the vhost or VB files, are those on the container as well, or are those on your computer?
Well, I mean, it's on your computer, right? But it's in the container, right?
Okay.
Yeah.
So if you pull that down again, like refresh it with destroy your previous Nginx configurations.
You just start a container, everything dies.
Okay, it's in there. Okay.
Unless you dig it.
Like if you remove the container, yeah. If you just stop the container, it still will exist.
Container, but imaging container.
Yeah.
So that Nginx container have persistent storage?
It does, but you don't want to use it for a lot of persistent storage. There's something called Docker volumes that they suggest you use, which I have one slide devoted to that, and we're not really going to cover it. I'm not as familiar. Are you using Docker volumes yet, or?
No, we just like, I don't really have it right. I think we have a volume. Well, I guess we kind of use that volume, but it's like not actually on the box. It's like in this.
Okay, right on. You're just mounting that. Yeah, you can do that too. With the Docker volumes, I think Docker will do some hand holding. It'll help you, give you some Docker goodness on top of it. But yeah, you could just mount it, you know. But yeah, so yeah, you can use it for persistent storage, but that's not really the true, the canonical use case. And then Chris, you were saying, did you get your question answered or? Okay. But yeah, so images and containers are two different things. I just want to, so we're pulling images from the repository, and that's our binaries. But you can have an image, but your application isn't running until you actually create and start a container. And once you do that, now you've got a running app.
And I guess you were showing, so like right here we have multiple images.
Yep.
And do you ever have like images conflicting with each other?
You shouldn't. So each image repository and tag should be unique combination. So that's the way you kind of avoid image conflicts.
Could you get like Nginx latest or Nginx not latest?
Yeah, totally good. And if the layers within the image are the same, it'll just reuse what's already on the host box, which is kind of cool. So you're not pulling total duplicates when you don't need it. I'll show that here in a little bit.
Do images ever depend on other images?
I don't think so, yeah. Closest would be like a Docker file where you say, okay, hey, my first statement is a from statement. I'm going to pull from a base image, and then I'm going to do some other stuff, and then I'm going to package this up as an image. But that's the Docker file. We'll get to that here in a second. But yeah, images, I think, are independent, right?
Yeah, if you do the same image twice on the same container, you can't, like, it'll automatically rename the old tag.
Oh, really?
So if you make a new container, you tag it over what was there, it'll go in and rename it like a new way for you, so that it doesn't like.
No conflicts.
Anything else, you purposely remove them.
Right on. No, that's good. Yeah, I haven't done that yet, but that's good enough. All right. So yeah, that's just kind of some of the general stuff. So the Docker architecture, again, this is more high level, and this is out of my depth. I just wanted to kind of speak to it. Underneath you have the Docker daemon, which was doing a lot of the heavy lifting of what we just saw, and that exposes its powers via REST API. But we weren't running REST, we were running command line instructions. And so everything I've seen about Docker usually uses the command line. I've yet to see anybody interact with the Docker daemon via strictly REST. But maybe you've seen that in action. I don't know. But,
I think the cloud daemon maybe we were talking about you for a little while. I mean, that's spinning up that way the Docker container and the code for you to do.
Okay. And so these pieces are kind of known as the Docker engine. And so, you're at your command line, you're writing your commands, you're invoking this REST API, and you're hitting the daemon. And that's so you can, interact with network container image resources, which we were just doing, and Docker volumes, not volumes. And so again, I'm not trying to get too deep into architecture because I can't, but that's kind of like the high level architecture. Again, the core takeaway is this is kind of where I personally tend to operate is at the command line, and I'm just trying to invoke the powers of the daemon. So Docker concepts, there are 5 big ones, and we've kind of touched on all of them already. So you have the engine, which we just talked about, the command line interface, and the daemon and the REST API. That's kind of the core Docker. And then you have images, which are the binaries. You think of these as like your build artifacts. You also have containers, which are your deployment artifacts. So that's like your running application. You launch containers from images. You have Docker files, which are human readable. It's like your source code for your images. So we'll look at a Docker file here in a little bit. You write a Docker file, you store that in your version control, and you later build an image from the Docker file. And then you have registries. So like your Docker hubs, registries are just a place for repositories, which are where your images are actually stored. And so,
individuals have images on Docker Hub?
yeah, absolutely. Yeah. Again, you'll have that namespace and things like Jay Wilder that we saw. I don't know if his name is James or John or whatever, but he's just a regular person, or maybe it's Jessica Wilder. I don't know. But yeah, so whatever your name is, if you would, you'd want to have your own unique namespace, but yeah.
How would you get your image to be considered more
Official?
Yeah, like he was asking about, how do you know whether the image is poisoned or not? Is there any type of best practices to check an image, to run a script, to do things and see if it's good? Or
Yeah, I don't know. Off the top of my head, it's going either to Docker Hub, or I'll show essentially there's command line, there's a search command where you can say Docker search Nginx, and it'll essentially pull up what we just saw, but it'll order it by like the number of stars and stuff like that. But yeah, other than that, I'm not really sure. Or just roll your own too, right? Yeah. That's why I've been start from official and just kind of build it up yourself.
So you maybe headed in this direction, but I mean, so you showed that pulling down Nginx to this empty web container, but right, you want to deploy your application in that. So is the strategy that you start out with the Nginx image, and then you add your code, and that creates another image, and that's what you then pull down, or can you somehow like command line sequence all these? Oh, I pulled out the Nginx, and then I install my stuff in it.
Yeah.
I mean, which of those?
There's a couple ways you can do it. So one, you can go into a container and run a container and make changes to it and bake that as an image. That's not the ideal way. You're not supposed to go into running containers. That's not the usual use case. I think the main way is the Docker file, which we'll talk about here in a second. You just start with the base image, and it could be Nginx, or it could be Ubuntu or whatever, and then each line of your Docker file will comprise another layer in the image, and that's where you kind of build up, and you can source files that are outside of the image as long as the Docker file knows the location of the file. That's how you can bring in your own code. And then again, that Docker file, you run a Docker build on that file, and that will create this baked image for you that has all of your custom code. So, yeah, good questions. Let's see, so registries. All right. So the engine, again, this is kind of above my pay grade, but I just want to show it. So we're already been dealing with the client and the daemon. This is image I grabbed from one of the books I read. But so the daemon here really is kind of all of this. So the daemon actually used to comprise all of this stuff, and what Docker has done is over time it's actually taken more and more responsibilities out from the daemon to where the daemon is essentially just that REST API is all it kind of deals with. And then underneath the hood, you've got container D and run C. And so container D serves to serve as the bridge between the daemon and these run C processes. And these run C processes essentially just create your containers, which are depicted here. And I guess I don't really know. I guess the key takeaway for me from this slide is that once upon a time, like I said, all of this was the Docker daemon, or I guess all of this here. And so if you wanted to upgrade Docker, I think it impacted all this stuff down here. And so Docker is, again, trying to make their architecture more modular. They've broken this stuff out to where, okay, when you go to upgrade Docker, you're just now upgrading this, and it kind of leaves this stuff in place. Or if you want to use a third-party component that implements this functionality, you can swap that in. Again, I'm not sure if that's BS or what, but that's, again, just showing Docker being user-friendly, at least as of right now, trying to come up with a friendly ecosystem. I think that's a huge thing, kind of breaking open their black box. So that's kind of the Docker engine to me. Images are the second component we've already talked about. Again, that's your app. It's in a standard portable file. You want it to be as minimal as possible because you're trying to spin this stuff up. This is not a VM. There are certain use cases for VMs, certain use cases for containers. So if you're looking for a full-fledged development environment, a container may not be the tool for you. But if you're looking to quickly sandbox stuff, containers are great. If you're looking to actually move stuff down a deployment pipeline. Containers are great. And so an image is comprised of a stack of read-only layers, and they're cryptographically hashed, so that's huge. And it's based on the contents in the layer, which that'll make more sense, I guess, when we look at the Docker file. And you can pull images like we've seen from Docker Hub, or we can use a Docker file to create an image, or we can use a container to actually create a new image. And again, I consider these build time artifacts. So, and these are just some of the commands that are associated with image. And actually, it's supposed to be images. I forgot that incorrectly listed. So yeah, let's just run some code just to kind of see what I'm talking about. Let's see. So before we were running Docker run, and it was doing a lot of stuff for us, underneath the hood, Docker run is actually running like 3 different Docker commands, one of which is Docker pull. So if you just want to pull an image, you just run the Docker pull command. And again, same deal. It doesn't see, this is the Apache web server. And I knew it was HTTP because I went to the Docker Hub and just typed it in. And I went to look for Apache. And I forgot Apache is like the Apache Software Foundation. So, you know, a lot of Tomcat and Cassandra and Maven, but this was the one that I wanted. And so that's how I knew to list it as HTTPD. So yeah, so we see here, this image that we just pulled down has 7 different layers in it. And, you know, it's gobbledygook to us, but you just kind of see that from the jump. And then if we were to run our sudo docker images, we'll see that we now have the 3rd image on here. All right. And so again, when you run docker run, that's the first command that it'll do underneath the hood. So tagging is another concept in image land. You can tag an image with multiple tags, I believe. And this is how you can say, hey, I don't necessarily want the latest version of HTTPD. If we go into here, we see that we're up to like 2.4 or whatever. But if for whatever reason I wanted just the 2.2 version of it, I would have to specify that when I ran my Docker pull command. Otherwise, I would probably get the latest. And so that's how tagging works in Docker, colon, and then whatever your tag name is going to be, or your version. And so then it's going to pull down, and you notice it says, hey, this layer already exists on the system, so I'm not going to pull this again. I'm going to reuse that layer that already exists, but there look to be 4 additional layers that we didn't already have from the first pull. And so now we've got a new image. And so you see, this is what I was saying, this is how the collisions are avoided. HTTPD latest in 2.2. So I don't think you can have any duplicates like this on your system. I think that has to be separate. We can also inspect images. So you run the Docker inspect command, and again, just your image name, and it just gives you a ton of information. IDs, repo tags, whatever. I think there's some stuff about port exposure in here. Somewhere, some environment variables that, could be helpful. And then you can also drill into your inspection, so you don't have to always pull back the entire list. You can just say, if for whatever reason you're just looking for the ID, I see this F flag being used, and it's for formatting, but I've never really seen a different format, so I'm not really sure the benefit of it, but that's what I've been copying. But here's just the ID, so as opposed to the whole thing. You can also traverse the JSON element with the dot, I guess, with dot access, whatever. And so here we've got just the host name, and that stuff is up in here. So you can inspect containers as well, same deal. And I think you get a lot of the same information, but I think there's obviously slightly different information you would pull from a container versus an image. And then if we want to remove an image, you want to, because, these images, they take up space, right? not a lot, but you see you can start to balloon up here. So if you want to actually remove an image, it's oops, what did I do here? Is RMI as the command to remove image. And so I have a problem though. I can't remove this image because we have a container that even though it's not running, it still exists that use this image. So if we look at just the containers that are out here, we got this hello world container. And so I need to remove this container first before I can remove the image. And so that would just be Docker RM just to remove a container. And you can either specify the entire container name if you want to remove a container, or you can specify just the first portion of the ID that's going to, oops, is it not working? As long as it's unique. So the fact that there's only one container on my system that starts with a 2.1, that's all I really need, and Docker will just kind of know what I'm trying to remove. And so then if I look now, we just have the one container, the Nginx that's running, and so then now I can go back and remove my hello world. And so if I'm looking for images, hello world is gone. So there's something to think about, which that kind of threw me at first. I assumed that if there's a running container, okay, you can't destroy its underlying image, but the fact there's a stop container and you still can't destroy the underlying image, it just makes, I don't know what the true relationship is between containers and images.
I don't think it actually when you create a container, it doesn't copy the image.
Okay,
Into the container, it actually uses the image to execute the container. That's where the shared process, that's where the shared space comes.
Okay, all right, well, yeah. Let's see, so we did that, remove the image, so all is good. Okay, so yeah, we're starting to clean up our playground a bit. So then containers, so now you actually want to start running. So we've talked about containers. So again, isolated processes, network stack, all that good stuff, spawning from image. You think of these as a class, image as a class and a container as the object, or think of an image as the blueprint and the container as like the cookie cutter subdivision home, but you can spawn multiple containers from the same image. Like I've mentioned several times, the container will run until it's finished executing its code, then it will stop unless you pass the D flag to it. And again, these are runtime artifacts, not build time. And here are just some of the core container commands that I've played with personally. Let's see here. You switch? All right. All right, so containers. So we are going to spawn a container from the HTTPD image that we just downloaded not too long ago. Yeah. So again, I ran this command, the run command. And you notice run, it didn't go out and pull the image or anything like that because it saw that we already have the image on our box. The port mapping. So the way this works is we have two images. One's Nginx and one is Apache, essentially the HTTPD, and they both are exposing port 80. But obviously on a machine, there's only one port 80, and this is where the port isolation, the namespacing comes into play. So what we can do with our Docker run commands, we can say, hey, on the host machine, map port 8080 to whatever this container's port is, which is 80, and we gave it its own name. And so, let's see, if we go to, so that's our Nginx, but if we go to port 8080, if I can click on this, we'll see, I guess, what Apache gives you when it wants you to know that, this web server is actually up and running. So again, two containers both thinking that they're being invoked via port 80 on the same machine, but all as well because we've got port isolation thanks to kernel namespacing or whatever. And that even works on, those are two separate images, but it would even work the same if we run another Apache container from the same image. But, here we've got a different port mapping, 777. It's going to happily spin up our container. You see now we've got 3 containers. We've got our Nginx. We've got our 2 Apache web servers going. And then again, oops, shit. So it's up there. So 3 web servers on the same machine, port 80, and everything's good. What's up?
So usually you use like these web servers with like some configuration files, so you don't just like Nginx. What would you like do here to say, okay, I have a continuing Nginx, but I have to provide my own configurations?
Yeah. So either we've got these things running. So the way Docker works is it's a system called copy on write. So for an image, each layer in the image is cryptographically hashed and is read-only, and that's just to make sure that the image is predictable. So whenever you run that image, you'll get the same thing. But when you spin up a container, the uppermost layer is an open write enabled layer. And so there you can maybe start doing some custom configuration on a running container. And then once you've made your changes, you can actually commit that container and that'll create an image from that. So that's one way that you can kind of bring in your own custom code. But I don't think that's the ideal way. I think the ideal way is to use a Docker file, which we're going to talk about here, I think the next slide. And that's where Docker file has its own syntax. And you first say, okay, hey, start from a image base. And then for each successive line of the Docker file, that's going to correspond to a layer in this image. And one of those, in their Docker file keywords, one of which being copy or add, and there you can maybe pull files in, right? So, oh. Is there anything I couldn't hear you? Oh, I guess, yeah.
You can replace a portion of the Docker file structure with a portion of the system.
Okay.
Yeah, so you can say for Apache, if everything exists in /, I don't know, it would be like HTTP root, you can say HTTP root on the Docker host is actually /var/ whatever.
Yeah, okay.
And so like, yeah, it's like the, if you're using Vagrant or maybe not Vagrant, like, you want to pull down your like Puppet file and stick it on the machine, and then you launch the image, the file is right?
Okay.
There's another program out there that you can use. I won't say use vaults. They were talking about it today. Quasi-parameterize your Docker image, so it'll automatically pull your environmental variables. So you can say you can launch your Docker image and say I want to launch it in my dev environment. Right. It'll automatically go to Vault and pull all the dev environment variables out. Yeah. Your path, your credentials, etc. Load it into that image, launch the image. Then when you want to run the prod, you just tell them you want the prod image. And it pulls that stuff out.
This Vault?
Vaults.
Yeah, I think that's a HashiCorp thing. So they've got Terraform, Vagrant, Packer, Nomad, Vault. Yeah. They're like becoming the Microsoft of like the deployment delivery pipeline. So yeah, right.
So if I have to, let's say I want to share my environment with some other developer in my company, I don't have only to send him the image, I also have to give him all the files that need to like use this.
Yeah, if you're in, well, now the image should be self-contained. What I was talking about was a Docker file. So if you want to send them a Docker file, you would need to also send the corresponding images. And for what these guys are talking about, I think you would still probably need to, if it's not bundled in the image, then yeah.
So there's no way of saying like, my image translates to an Nginx configuration file, but you still have to like give the image and give the configuration file and all the other stuff.
You can make it in, it just makes it like harder to change it.
Right.
Now your production, your development image is completely different and not reusable, right? Where if your configuration file, you attach that, you pull that and post it, now you can use that image.
Right. Yeah.
It depends on what you want, or whether you want to build an image over and over and over again every time you choose it.
Well, maybe you want like the image that is web app code would be big. I mean, you want that big image, but the configuration stuff to different.
Yeah.
That into a
Right, exactly. Exactly, that's what I would see as.
I hope it's like, if you could do something like that.
Would you really want your code base baked into the image though? Because you're changing it iteratively anyway.
I mean, so I want my build process to maybe continually, every build makes another one of those images. Okay, just put there.
I do. Let's see. Okay. Yeah, I'll say all that. To me, it seems like, yeah, you want to keep it generic enough. And you don't want it to be overly big because your container is supposed to be somewhat small, I guess. But at the same time, no, I'm just kind of rambling. Ignore me. Okay, so hey, all right, so we got rid of Hello World. That's gone from our system, but we want to pull it back in again and do something with it. So again, we could do the Docker run, but we're just going to pull Hello World. Again, it didn't see it on our system, so we're going to go out and fetch it. Docker create is the other command that when you run Docker run, this is the second command that is running underneath the hood. So now, let's see. It's still not running. Let's see what I have to do. Okay, yeah, so I created a container for Hello World, and that was just based off of the create command. So again, Docker run will run Docker pull, pulls the image down. It'll run Docker create where it'll create a container from said image. And then the last command that Docker run will run underneath the hood for you is Docker start. And so that is... So, yeah, also, let's see, didn't really show it. So when I created that container, I actually passed in the name myself with the name flag, just in case somebody missed that. And so that's why the name of it, and I'm sorry this isn't lining up a little better, is HW, as opposed to like small Galileo or something like that. And I also named the Apache containers, which is why they're named what I passed into the command. Let's see here. So I'm going to actually start the container up. I'm passing in the I flag, which means run it interactively, which means we'll be able to see what the container did. And you see here's the hello world message from Docker. And again, I'm just trying to point out Docker run is a nice command that'll do all three of those things for you, which is a big part of your software installation life cycle. Let's see. Oh, yeah, and I'll show you just real quick, just one of these inspection commands on a container. Same deal as the image. If you want to get into a container, you just run Docker inspect, list out the container name, and you can pass in the actual stuff that you're trying to inspect, and it'll pull pretty relevant information out for you. Okay, and then finally, if you want to stop a container, use Docker stop. Again, Docker tries to make this easy and intuitive. That stops that. And then if you want to remove the container, you can just do Docker RM. So that's that.
I don't think we're promoting real quick with the dash I running interactively there.
Yeah.
Correlated to the programming is kind of like your debugger for your.
Oh. That's if you want to get into the terminal.
Oh, but you're just getting that output.
That was, yeah, just seeing the output. Yeah. Otherwise, it would just run and finish, and you wouldn't see any of that stuff. But yeah, actually, let's do.
So when you do dash I, you can't actually type on it.
I don't think so, but let's see. Nah, okay, yeah. Yeah, that was okay. So it's when you do Docker run, let's see. Images. IT. Oh, what the fuck? Yeah. Give me a second here. Tell you what, we're gonna, some of the code down here will tunnel into the terminal. I'm not really sure why that's not working. Obviously user error. Let's see. All right, so that's containers. And I'll say you guys are kind of jumping a lot of the presentation, which I guess is a good thing. So easy software administration. This slide just want to really show, okay, these are the different elements of, software administration. And here are the Docker corresponding commands that are associated with each of these things. And depending on what you're trying to install, it can be a total pain in the ass. And then here we've got this Docker run, which, is not really, there's no real command, no equivalent in traditional software administration, that will pull it, that will install it, start it, but Docker run does all that for you. So again, Docker is trying to make your life easier, and I guess trying to get paid at some point. So Docker files. So yeah, these are recipes for building images. This is the human readable source code of your Docker empire. The way Docker there are Docker file keywords that I've kind of highlighted in this simple Docker file. And each one of these keywords corresponds to a different layer in your image. And so the way I've seen all Docker files is you start with the from statement, and this is an image. So Debbie and Jesse, that's a Linux operating system, and it's one of the versions of it. That's the base image you're going to start with. Again, since nothing's been specified, assuming you're not passing any parameters at runtime, this is going to go out the Docker hub and look for this. And so that'll be the first layer in your image. Then maintainer is another Docker file keyword, and that's just you signing the image. And so here, you've got some stuff here. That'll be a second layer in the image. End is to set up environment variables. So you see that in here. Run allows you to just run, Linux commands, or if you're on the Windows side, you can, run PowerShell or whatever. But these are all on the same line. You got the backslash that says, okay, treat everything here as its own command on the same line, and all of this stuff will be baked into the same image. And you notice there's a separate run command here doing something similar, just running some code. And this is, for anybody that's installed Nginx, this is familiar territory. And so you got that. Then you're exposing ports. And so remember when we were doing the port mappings, we were mapping to port 80. This is why we were mapping to port 80, because it was exposed in the Docker file itself. Had this been 999, we would have wanted to, map to a 999 port. And then command. I think the way that a lot of Docker files work, and definitely correct me if I'm wrong, I just started messing with Docker files. You want to usually end off on a command or an entry point, which is another keyword. And that what this says is, okay, when I go to, I'm going to build an image from this. So I build an image. And when I run a container from this, I want to obviously go through all this stuff, and I want this to be the last thing that runs. And so when you're running an Nginx container, you want to actually invoke Nginx and kick it off and start it running. And so each one of these layers will be cryptographically hashed based on the contents of the line itself. And that's how, like with the HTTPD example, it was able to say, okay, hey, I'm installing 2.2. I've already seen this top image. I see the same cryptographic ID. The hash. Let me just use that because I know it's going to be the same content.
Does command have to be the last thing, or have 3 processes that will start?
Yeah, I don't know.
That's the command key essentially are setting
Yeah. I don't know.
I think you do the processes in the container. I think you only have one process being live, right?
You're supposed to.
You're supposed to only have one process running in the container.
Yeah.
Some people cheat that by making a process a shell script inside a container that executes additional processes.
Yeah.
It's considered bad practice.
But as far as having multiple command statements in a Docker file, I'm not sure. Right now, you twist my arm, I'll say no, but I don't know if that's right.
Yeah, entry point, and I don't remember what entry point, the difference between entry point and
Yeah.
Like, you can have as many runs, you can run as many.
Yeah, runs, yeah.
You can only have like one main process, I think, and you can infinite flags, right?
Why is that considered bad? I mean, our system is three cooperating processes.
It's like the one that runs the image, like, you'll see images with like tail leader command, because they want the image to, they want a command to run and the image to stay alive, right?
Okay.
I think you're supposed to, if you want it to stay up, you're supposed to pick a command that runs infinitely, right? Like express or
Gotcha.
Apache.
The reason it's the best practice to only run one process is for composability. Like the no principle, Linux uses composability. You get one functionality that you do it well, and then you can compose those into multiple systems.
So ideally, you would not stand up the system with only one container. You would have one for Apache,
Yeah.
one for MySQL, one for Redis maybe.
Right.
And those would be independent from one another. So if you need an additional Redis server, you just stand up another Redis container and you configure it, you got it.
So, I was surfing through Docker's documentation for problem because they had a section that specifically titled best practices for running Docker files. So I'll get that in a couple of minutes.
Yep. But yeah, then you can stitch all that stuff together, like the 5 different containers, or you can use like a Docker Compose, and hopefully that'll kind of just spin it all up together for you. But yeah, so like I said, twist my arm, I'll say probably just one command or entry point per, but I don't know. And so just, driving home the point, each one of these would correspond to one of these layers. So this is obviously a different image, but I think there are 7 keywords here. So there would be 7 layers baked in here, read only, smashed together, I guess shrunk maybe if possible. And that would be your image. And then you would run containers from that. So you notice we do have the 2 run commands. And so it begs the question, well, why couldn't I just use one run command and just lump all this stuff under here? And that would save, each layer cost. So that would maybe save a little bit of overhead as opposed to having 2 run layers. And so I think as far as best practice is the way you want to set your Docker files. Again, Docker will reuse and try to be as efficient as possible. So when it starts going through, if it sees that there's no difference, it'll just kind of quickly spin through this. And we'll see that here in a little bit. But as soon as it finds some kind of change, then it'll essentially start from scratch for all the layers down beneath. So say these things may change more than this stuff, you want to keep these separate to where if you want to build images from this Docker file and you make modifications or whatever, if this stuff doesn't really change as much, keep that separate and keep it up towards the front. So you're spinning through this as quickly as possible. And then once you hit something that actually changes, okay, well then the rest, we have to kind of go through the rest of the image build. But I think that's probably the main reason to separate out run commands. Otherwise you would just say, hey, just have you would never want to see this, stacking 2 different run commands on top of each other if you could just bolt them all together. I think it's just stuff that changes for this different frequencies. You keep it separate if at all possible. And I don't know if that's how you approach your Docker file creation or what, but. Okay. All right. Yeah, this could be all for naught. I don't know. This might be just more academic. But yeah, anyway, so this is what you would actually, if you wrote this up, you would store this in GitHub or TFS or whatever. Well, probably not TFS, but Bitbucket. And so we'll look at some Docker file code. And I think some of the stuff that we've been talking about will get addressed here, I think. All right, so we're gonna build a Docker file, which we have not done thus far. We've just been pulling images from Docker Hub. So let's see, we're here in the home directory. We just created a demo folder, which is where we're gonna store our Docker file. Nope, that's not what I want. All right. and the Docker files that we'll be looking at are going to be super simple, like romper room, Mr. Rogers simple. And doing a Docker file, hopefully we have more complex Docker files. But yeah, so here, from statement, Ubuntu 16.04. So making sure we get this and not necessarily just the latest Ubuntu, which I guess is up to 17 now. And then we're going to just run, traditional update commands. And that is the Docker file. And so then now it's like, okay, well, that's great. Now we want to actually build an image from this. And so we're going to use the Docker build command. So Docker build, and then the tparm is to actually tag this image. So that'll be the image name. I tend to usually tag all the images, but I don't know if Docker will just create a name for you if you don't tag it or what. But the period, that's the present, the current directory, this, where the, oh no, actually, this is a blow up. Okay. Sorry, let me try something real quick. Okay, yeah. So yeah, this should blow up, and it does because, the Docker file doesn't exist in this directory, so I need to drill down to the directory where the Docker file exists, and then I should be able to run this code. And I only drill on the periods just because if you're reading this stuff like in a book or whatever, it's really easy to kind of miss the period. You think it's just a end of the sentence. It's like, no, that's a pretty critical piece of the code. And I'm assuming you could probably put your own path to the Docker file if you weren't in the same directory. But again, once we run this, it's pulling from Ubuntu. This shouldn't take too long. At least it didn't at home. There we go. And you see all the stuff that's just happening. And so now we've got a new Docker Ubuntu clean. Pull that, and then it also looks like it pulled the initial Ubuntu image and threw that on our system. So I think if we were to try to do anything else that uses Ubuntu 16.04 as its base, it'll just use this layer or this image as opposed to bringing out another copy of it. And so that's our image, and like I said, it's not, stellar code, but like this we would store in GitHub or whatever. And so then now if I want to actually run a container and actually drill into the container from the image, I can run Docker run, get out of here, the I and the T. And the T is what's going to get us into the actual terminal. I'm referencing the image name, Ubuntu and clean. And then this is, I guess, the shell I want to be in when I actually get into the terminal. And so you notice the prompt changed here. So we're no longer on the we're on the host, but we're in the container. And from the container's point of view, we're in a totally different world. This is
you logged into them.
Right, exactly. Yeah. Let's see. Do I have any code? This stuff here. Okay, yeah. So on a Ubuntu box, right? So Python comes pre-baked, so we should get a Python version here, but it's like, well, what are you talking about? There's no Python. And that's because the container is completely oblivious. So we'll exit out of this. Just know that we have one Ubuntu image and a container that does not have Python. So let's see. So we're going to modify the Docker file, and I think we're going to add Python to it. I think is what the change is going to be. Let's see. Yeah. So only change we're going to make is to this last line, another run statement, and that's the only change. So that's that. And then we're going to build another image, but now we're going to call it Ubuntu Python because it's going to have Python on it. And so you see how fast it went through those first couple of steps, and then now it's like going through and grinding. It's because it reused the previous image layers. All right, so we have a new Ubuntu image that has hopefully Python in it. We're going to drill into it. We're going to spin up a new container called Ubuntu Python bash, and if we run the Python version, here's Python. Well, 3 + 3, 6. Pretty cool. All right, and then we can just get out of that. let's see. Okay, so now we're actually going to copy in a file that's outside of the Docker file itself. So in the same folder or same directory, we'll create a Hello Pi file. Pretty basic stuff, just gonna print. And then we're going to add these 2 lines to the Docker file. So copy in Hello Pi. I guess that's from the current directory.
You just switch out command for entry.
Yeah, let me run it with entry point right now. Yeah. But yeah, we can try that too and see if it has any difference. All right, so now we're going to build another image based on that Docker file that's now changed and is also incorporating another file. We're going to call it Ubuntu HW for Hello World. And that was pretty fast, yeah. So I think it was so fast because those first 3 layers were all the same, and it's just the bottom 2 layers were the only ones that changed. So then, if we run, I think I need to. And you say prints off hello world from Python, so kind of cool. Okay, so then now we're not going to touch the Docker file itself, but we are going to touch the code that we've created. So, oops. So we're in here, and we're going to import Python library. And we will build an image, another image called HW variable 1. And again, we didn't touch the Docker file, we just touched that outside code. So again, pretty fast in the first few layers. Looks like this may have changed a bit. Oops. And then now we're going to run a container based on this new image. And the code was just, you pass in a variable. It was looking for the name variable. I'm sorry, I should have mentioned that. And it'll say it. So I'm using this E flag to pass in an environment variable at runtime. The variable's name is name, and the value is Jones. And it's going to say hello world from Jones. And if we were to do Jim, same deal. Jim. So again, didn't touch the Docker file, just touched the outside code, and we built a different image. And let's see, I think this might be the last. Oh, we're going to include the environment variable in the Docker file now. So one change we will make is we will add this environment name. Oops. So that's that. And then we will build another image based on that Docker file. And you see how much stuff is changing? It's because we made a change towards the top of the Docker file. So it saw that difference. It was like, oh, okay, well, from here on out, I'm going to assume this is like a fresh build or whatever. And so it's doing all that. Let's see. And then we're going to run a container, and it's going to say hello world from Henry. And that's because in the Docker file, we're utilizing that environment variable. You can also override environment variables at runtime. So same Docker file or same image, we're going to run a container, but now we're going to pass in environment variable name of Jones, and it's going to override the Henry that was in the Docker file and use Jones instead. And I think this is still more the same. I was just going to put in the maintainer layer as well. And again, maintainer is just you're signing the Docker files, not really changing anything. And I guess I'll do it. It'll be the same deal. You'll see it just takes a Docker file a while to build because it sees a difference and it thinks it needs to redo everything from scratch from the point of difference. So again, I'm going to kind of spin through. So yeah, when you're doing the Docker files, if you have any inkling that certain things won't change, keep those towards the top of the Docker file. Or if they're heavier processes, you definitely don't want to have to run the whole thing every time for that kind of stuff. Keep your changing code towards the bottom if possible. And then, yeah, we're just running the same container. So that is that. What the hell was I doing here? What is this? Oh yeah, just showing how fast it is now to build a different image from the same Docker file. Nothing's changed, and you see how fast it went using the cache. So registries, yeah, we're winding this down now. So again, Docker Hub, registries are places where you house repositories, and the repositories store your Docker images. So Docker Hub is the biggest container registry that I'm aware of. Hosted by Docker. You have the public and private repos. You have the official versus it's not no name, but I can't remember the cool term for our repos or our registries. But again, official connotes more trustworthiness. There are other public registries. You got Amazon's got their Elastic Container Registry. Google's got one. Quay.io, which I've never heard of until coming up with this presentation. Artifactory is another. And then you can have private registries if you've got sensitive images and you want to keep that kind of housing on deck. You can do that as well. And so we've already kind of looked at the Docker stuff. You can drill in. I think we looked at that a little bit. But that's really helpful. It helps you have trust in the images that you pull. To the terminal. Oh, yeah. So just like we saw this stuff here, you got number. So for HTTPD, no, that's not what I want to do. So if you run Docker search in the name of whatever image that you're looking for, this is really jacked up. It'll by default list it in descending order of stars to give you the most trustworthy stuff up top. And again, that kind of corresponds to the stuff here, but I'm not really sure.
Search for Apache there.
Oh, thank you. There we go. Right on. There we go. And so, yeah, so the HTTPD official, the Hypriot or whatever, BusyBox and CentOS, that's the same stuff that we've got over here, a little more granular. It gives you kind of, more specific number of stars, gives you the OK official tag designation or whatever. So, for whatever reason you don't want to go out to the website, you can just hit that from your own terminal. And you can also filter on the terminal, which is kind of cool. So you can say, hey, I just want stuff that has 10 stars or more. So, oh, wow, that's really horrible. Yeah, you got the HTTPD, you got this one and this one. And it corresponds to the top three that we saw here. All right. So that's pretty helpful. Let's see. All right. So yeah, this is kind of just the Docker flow. So I wish I had a better picture or maybe a more separated picture. But yeah, I think of one of the paths of the Docker flow is starting with a Docker file, then you build into an image and you can maybe tag the image. And then from said image, you can run or create a container, start a container, or just run or whatever, but that image becomes a container. And then, like I said, the images are read-only, but once you start a container, you have a topmost layer that's write enabled. And so you can actually make changes to your containers and then run Docker commit, and that'll change the container, that'll create an image from your modified container. With images, you can push these to registry, which I've actually had a bit of an issue pushing to my own registry. Otherwise, I would show that code, but it's Docker push. Probably not. So yeah, maybe offline we can talk about that.
So if you make a change in a container and then do that to create a new image,
Yep.
let's say that you originally created from the Docker file, right? Now you've got a certain copy saved with the original Docker file was.
Sure.
I mean, you could obviously go back and like make the equivalent change in the Docker file by hand. Is there any sort of more automated way to say, oh, write yourself a Docker file?
Right. Not that I'm aware of, or that's not like homegrown or whatever. And again, going into the containers and making changes and then creating images from that, I know that's not like the preferred method, and maybe that's one of the reasons why.
Right.
Right. But I'm sure there's ways, especially if you ironically start thinking about using some of the traditional configuration management tools like Assault or Puppet, something you can have it just kind of watching for changes or something like that, and maybe upon changes it could invoke some code. I don't know. But yeah, that seems like you're trying to manage two sources of truth at that point. And then also, finally, which I've yet to see this at all, but I guess images can live elsewhere other than a registry or on your own machine. I guess you can store images in a database, or I guess maybe like S3 or something like that. Just
You can't do that export. It'll give you like a zip file like Linux.
sure, yeah, I got you, yeah.
So you can like ship them around if you have like offline servers that you don't want to attach to this. If you have like internet-only stuff, you can like run a CD or a drive, and then you can import the image from like a compressed file.
Okay. Yeah, just until I came across this image, like the few books that I read or whatever, just nobody really talked about that at all. But,
And I think you can export the container as an image, or you can save the containers off too, so you can give someone like that copy of the running container.
okay.
It's like you put it there.
Right on. Oh, okay. All right. Well, and so I guess, okay, you gave me a copy of a running container, so I get it on my system. Do I still need to run it, or is it?
Yeah, I think it just loads in like an undone. It's just there. And then
Start it up. Right on. So containers versus VMs, we already kind of covered this like a while ago, but I guess I probably should have had this slide earlier. VMs relying on the hypervisor, hidden hardware resources, bringing their own OS, bigger, bulkier, slower, but they have their use cases. And from what I understand, I think they're trying to like I think containers are like forcing the VM folk to step their game up to where VMs are starting to become faster or whatever to spin up. So, if it gets to the point where a VM and a container are equally speedy, I mean, I guess the VM will always hog more resources, but, yeah, definitely a place for VMs, as we will see next month with Matt's presentation with, what are you doing? Vagrant. So yeah, if you think about the software stack, you got, especially from a cloud point of view, your underlying virtual machine. So just, bare bones operating system on it, whatever. And then maybe you want to customize that, harden that a bit. I sit right next to our security folks, and this is all they do all day. And then you think about, okay, now we got a hardened machine. We're going to, start porting some software on here. So just some applications, pretty, generic. But now we want to actually, harden these, maybe, or configure them or whatever, permissions and whatnot. You got that. And then now we're actually talking about, okay, your application logic, your algorithms, your company's secret sauce. And, this is just kind of the way I think of software stack layers. Docker, and I'm assuming other containers kind of live up here. If you're talking about provisioning a base image, you may want to look at something like a Terraform or CloudFormation for Amazon. I'm sure Google's got their version of it. If you want to harden an AMI, tool like Packer is probably where you want to be. You could probably still use CloudFormation for something like that. But then once you start getting off into the application specific stuff, that's where Docker especially, and I think other containers kind of come into play. I just want to show, I'll quickly show the process isolation, which I guess we've already kind of gotten a sense of, but here we're on the host system. And so, let's see. So just kind of listing out all the processes that are running, I guess, or just the PID. So this is on the host system. This is what the host sees. If I spin up another, where are you at? All right. Jeez. Same deal. This is the exact same VM. It'll show the same stuff. It's killing me. All right. Let's see. But if we were to drop into a Docker container, we'll go into the, all right, so Docker exec allows you to jump into a running container, and I think I still needed to use the I and the T flags to get in there. This BB corresponds to the container ID. Again, I could have used the entire container name, but I just opted for the container ID, therefore, so I didn't have to type the whole thing in. So this should take me into our Apache container, which you see Apache 2 is where we are. That's where we're at. So if I run AUX in here now, you notice that there's a lot less stuff happening inside a container. You see obviously a lot of HTTPD stuff, right? And you've got a PID of 1 over here. But if we were to look at the host system and look for the HTTPD stuff, where you at? Right here, right? And so its PID actually is 3657, but to the container, from the container's point of view, it's the king of the world. It's the only kid on the block, and it's running as root. And this is all that's happening, even though, there's obviously more stuff. And you know there's no Nginx, even though there's another Nginx container running. So if I were to open up an Nginx container, it'd be the exact same thing. Oops. Let's see. So now we're in Nginx land. Oh, yeah. And so the PS, so yeah, remember Nginx, these are containers running from 2 different images, right? But PX is not even available on the Nginx image. So I actually had to do this. This was literally the last piece of code I wrote before I came here. And that's probably what yeah, there you go. Yeah, help, I think it's like 4 megabytes.
Yes.
Yeah, like you can just email it. Right. That's just crazy. It is an operating system, but you can just email it to somebody. Don't worry about zipping it up or anything. Just snail mail it. So.
Processes that
Yeah.
your HTTP container, right, are visible from the host. I mean, are they protected in any way? Like if you kill them from the host, they would die in the container?
I'm going to pass this to you, man. Yeah. I mean, I guess, yeah, right. If you kill that.
When you did that, I was initially expecting to see that you wouldn't see the HTTPs on the host, and that somehow you'd see some Docker process.
Right, masking it or whatever.
Yeah, or, that it's more like the processes really are there, so any sort of protection is there.
So I think from the host operating system, it's a little bit less protection. But from the inside the containers, you're isolating the processes.
Right. The host is protected from the container,
but not vice versa. Yeah. If I want it, is it just kill and whatever the PID? Is that how I kill?
Kill that.
Kill -9.
Kill what? Dash?
-9.
I think it was. Oh shit! No.
Like 36.
57 maybe. There we go. Oh, yeah, no, you're totally right. I should.
You still have the terminal open from the container?
It was the Nginx one, which is crapping on me right now. Let's do Docker PS. All right. Yeah, one running container, man. So yeah, we killed that container from the host by just.
Yes, kill the, that's the running.
That was the.
That's the command. The command's running in the
Let's see. Is it you? Yeah, I think I just wiped this one out a while ago. Yeah, dude, I think it was this one. So, Nginx is still fine. Yeah, I wanted to, I mean, so I'm not really sure what's going on with this thing. I mean, I thought this was the code that I used to get this thing installed on there. So, say it again.
Does it need space after
Yeah, it says unable to locate package prop.
I don't know. But it was going to be cool because you would have seen Nginx, would have just seen the Nginx processes. Yeah, anyways, that's what I got. That's one last gasp, man. Sorry about that. Just the last few slides here. So we've already kind of touched on this, but, you know, like right now, if I were to list out, we'd see a bunch of images, and I guess only one container now, and we've only been messing around. So container sprawl is a thing that happens. So we can manually manage that. Container orchestration, like we were talking about with Compose, or, each container being its own separate process, and then you want to kind of knit containers together. Who orchestrates that? And then failure and recovery, containers do fail. And if they do, again, a human hand can be there to kind of bring up a new container. But, ideally you want some kind of automated process or service to manage that. And so this is where we get off into the container management space. So these are just some of the ones I'm more familiar with. Amazon's Elastic Container Service. It's AWS specific, so that's the rub. But if you're using just AWS, you want to use containers. They do a lot of hand-holding and give you a lot of sugar on top and make life a lot easier, to where they will handle, service discovery, fault tolerance, scaling up, scaling down containers based on your, if you've got cloud watch metrics that are thresholds being hit. ECS works nicely. Kubernetes I haven't actually worked with, but that seems to be kind of the number one container management service. It's cloud agnostic, it's container agnostic, but I guess it's maybe a slightly steeper learning curve. And then you have Docker Compose and Docker Swarm. Like Docker Compose is used to kind of knit different containers together to where you can have a full-fledged application without trying to bake everything into a single container. And then Swarm allows you to run, I think it's a swarm of Docker containers. And I guess you can use Swarm with Compose to where you can have, say, an Elk cluster in Compose. You can have maybe 3 of those clusters running, coordinated by Docker Swarm. So, and there's other stuff, like I know HashiCorp's got Nomad and other services out there. That's like the service discovery piece, I think.
It does like health checks on containers.
Okay.
I think you can put code in there that says it actually like checks into the console server.
Okay.
So you can have your stuff like restart or stop.
Right. Yeah, I know ECS gives you that same functionality, and I think they're running essentially console underneath, so you're not directly hitting console, but through ECS, you're kind of managing that. I don't know if Kubernetes works like that, or if you got the same thing. Okay, so, and again, I think console, I think that's a HashiCorp thing. So,
I think that was one for two. Is like this one thing, the container being up versus all the things under in the container. Like if you bring up your web app, but then it has to make a bunch of external connections and those die, you can have like console flag on those, and they'll actually be like, oh, actually I'm bad.
okay.
Even though our process is good, like
Yeah. I didn't even think of that scenario. That's cool.
Yeah.
Wow. Yeah, I just thought of the first level health check, like, am I alive or not? But yeah.
I think you could like tie into it with a bunch of applications. You can have it watch like a bunch of processes.
That's cool. Yeah, so that's pretty slick. So, these are getting better. They're trying to abstract a lot of that stuff away from you, but to give you all that goodness underneath the hood. The Docker ecosystem, and these three I'm more familiar with. The Docker Container Engine, which is what we've been talking about today. Swarm and Compose we talked about. Docker also has Machine, which allows you to manage Docker hosts remotely. Docker Data Center for enterprises that want to kind of, own their own Docker farms. And Docker Cloud, which I'm assuming is kind of like a cloud offering with Docker as a first-class citizen. I could be wrong, though. And then we have Docker Hub, which they didn't have a cool little logo for that, but we've talked about that. Docker Store, which I'm thinking Docker Hub is going to ultimately transition to, but I thought it was essentially just for commercial images, but it looks like it's for free as well. And if you go to Docker Hub, they always seem like they're pushing you to Docker Store is a new place to discover Docker content. So go in here. So let's see, Nginx. So click on this. See, we've got dollar amounts. Now, granted, this is free, but if you want some kind of paid software, I'm thinking like maybe Bamboo or something like that. They probably didn't want to have a free image out there, but if there's a paid version, so this is kind of like the AWS community marketplace. So that's some other stuff in the Docker ecosystem. And there's Docker registry, which I'm really not sure what that is, but the key takeaway from this is kind of what Docker's plan is. They obviously would love it if all of your container services were served by them, and they're trying to provide tools for every container need. But again, for right now, officially, they are playing nice with everybody else. Now we'll see if that remains the case if they, as they get bigger. But, I would imagine this ecosystem probably looked a lot smaller like 2 years ago. So, we'll see. Docker volumes, like I mentioned earlier, I'm not really going to touch on today, but that's important. You don't really want to persist your data in these containers that we've been spinning up. You don't have to use a Docker volume, but according to Docker, go figure, their preferred mechanism for persistent data is to use their Docker volumes. This is from the Docker docs. I just try to highlight some of the selling points. You could safely share volumes amongst multiple containers. I don't know. I didn't really fully understand this. A volume does not increase the size of containers using this, I guess. Yeah, it's just accessing the data. So for the Docker follow-up, which I really want to do sometime early next year, definitely want to talk about Docker volumes and that. So this has been a mostly positive presentation about Docker, but there are reasons to avoid. If you're on Windows 2012 or earlier and you want to actually run Windows containers, Docker's not going to have anything for you. It's 2016 or later, or Windows 10. If there's any security or SLA issues, our security guy's name is Fred, and he was going on and on about containers, and I just threw this up here for Fred. So if there are concerns, The lower level infrastructure stuff. So at that base level and the AMI level, the OS level, Docker is not really going to help you out there. And then it is still a young platform, even though the technologies that it leverages are decades old. It's still Docker in particular is still an evolving ecosystem. So especially on Windows, Windows has been kind of brutal messing with these containers. So those are some reasons to avoid. Next steps, like I mentioned several times, I want to kind of get into Docker volumes, and even if we don't show like massive volumes being managed, at least showing more data than what we showed here today. The Docker file, obviously those are very simple, so I want to show more complex Docker files, Compose and Swarm or Kubernetes or whatever, seeing containers actually managed as opposed to just working on a single container, and then possibly showing Docker in a continuous integration delivery pipeline would be great. So I think the resources, yeah. So a lot of the images you saw I stole from this Docker Deep Dive book, which is phenomenal. But if you're new to containers, I would suggest maybe starting with this Pluralsight course. Pluralsight is about $30 a month, and they've got a boatload of well done videos, hours long videos on different technologies. But the containers and images big picture was really, really cool. It was container agnostic. And the guy was just talking about, I think it's Wes Higby. It just really helped me kind of get the container image stuff in my head. And that's, I think, 3 hours. The Docker Deep Dive, again, on Pluralsight. I didn't watch that course. It's by Nigel Poulton, but it corresponds to the Docker Deep Dive book, which I read, and the book was phenomenal. The Docker book also by James Turnbull is pretty good, and that's kind of between that and this containers course, that's where I started. And this guy's written some other stuff. He's got a book on Terraform and a book on Packer, so the only Packer book I know that's out there, so that was pretty helpful. This is just a good blog that came at a helpful time when I needed like some reassurance. So I threw this up in there. And then the Docker docs, I actually want to get off into these a little bit more. Chris has been, I guess, going through those, and they seem like they're pretty clean and pretty helpful for documentation. So, but yeah, if you are just getting into containers, I would suggest messing with this course. I think Pluralsight has like a 7-day or a 30-day free trial period. And then I know there's stuff on lynda.com.
Well, and actually on Pluralsight, there was I don't think it's one of the ones listed up there, but there was another one that gave an actual example of starting up with a Java FullStack app.
Yeah. I'm going through one that's doing something with Jenkins, and I can't remember what else, but yeah.
Maybe one of those, but I know I definitely ran through one that ran through Java.
Yeah. Yeah, no, if you go on Pluralsight, there's like 20 different Docker courses, so obviously stuff that's from like 3 years ago you may not want to mess with, but they got a lot of good stuff and more advanced than what we've covered here. So I think that is truly it. So yeah, hope you guys enjoyed that. Got some questions answered.